Good morning, good afternoon, good evening to all of our friends and viewers live around the world. We're excited to be here today. Welcome to 60 minutes of unscripted .NET entertainment. As doctors of .NET, we prescribe healthy choices in .NET. I'm your host, David Pine, with co-host Myra Wenzel, and I'd like to welcome today's guests, Bri Achtman and Luis Quintanilla. Say hi.
Hey, folks.
Hi, everyone.
Hopefully I didn't incorrectly enunciate your names.
It was close. It
was close. Oof. I do apologize. So we're excited to have you guys. What are you guys going to be talking about today? And maybe introduce yourselves and say a few words about who you are, where you're coming from, and what you represent.
Sure. So my name is Bri. You might recognize me from the community stand-ups, machine learning community stand-ups. Both Louise and I host those. But yeah, I'm the PM for ML.NET, and we will be talking about ML.NET today. I'll hand it off to Louise.
Awesome. Yeah. So like Bri said, we might recognize me from the community stand-ups. I am Luis, and I am a content developer on the Microsoft Docs team, working across various products, Azure Machine Learning, ML.NET, and .NET for Apache Spark. And yeah, just excited to talk to you folks a little bit about ML.NET today and machine learning in general.
So I've noticed, I think your beard has gotten longer. Like every time I see you, it's just a little bit more.
Thanks.
Like
I've been working really hard on this. I'm glad someone noticed.
Oh God. Yeah, no, not you, Bri.
Oh. I mean, it is No Shave November, right? Like.
Oh yeah,
that's
true.
my excuse.
Awesome. Why don't we just jump right away into our checkup doc? I'm going to add this real quick. So today's checkup doc is a tutorial, actually, and it's on how to predict prices using regression with Model Builder. So ML.NET is an amazing product, as you'll soon find out in the hallway track. I'm not very well versed with this tutorial itself, but I think it's very relevant to the topic at hand because I don't want to forecast too much information here, but it's my understanding that we're actually going to see some demos with this tutorial specifically. So this is the doc that would walk you through how to do these things that you're going to see in a little bit, which I think is super, super exciting. Is there anything? Oh, taxis. So what are we doing with taxis here?
Yeah, so in this case, the problem is you would like to have a better way to predict or estimate sort of how much you're going to be charged depending on various factors, right? So how far you've gone, how many passengers you have in your vehicle, right? So it's very much like, if I think Uber has one of these where it's like before you even, schedule a trip, it will tell you, hey, we estimate that this is what your ride fare is going to be. So you could kind of do the same thing with ML.NET. In this case, you're using the tooling Model Builder to build that. Later on in the hallway track, we're going to talk a little bit more about the problem is going to be the same, except we solve it just slightly differently. But at the very least, this can serve as a base. And this is going to show you how you might want to do and try to solve this problem using ML.NET. So, yeah.
So I'm really curious. So, I mean, talking about taxi fares and stuff like that, what are all the variables that are taken into account? Like, is it just distance or like a GPS, or does it actually use other variables that it can account for, or like what?
Yeah, so that's the really cool thing here. It's so in this case, it's very naive about it, and you have to basically input all those things, right? Like such as the trip distance, and I believe it's in miles, how long the ride is, right? So for example, it might be 4 miles, but if you're stuck in traffic, right, those 4 miles could easily turn into 2 hours, right? And that certainly factors into it. And if you were to do this all by hand, you certainly could, right? Like, if there's 2 passengers, it's, 50 cents per extra passenger, right, per mile, whatever. The thing is that eventually those variables, right, they get very hard to code, right, in traditional programming sense. So by you providing examples of previous and historical data, right, machine learning, in this case, ML.NET, helps you basically try to define the rules without you actually going in and putting in a whole bunch of if statements, right? So in this case, this is just some of the features or some of the inputs that are used to help you determine what that fair amount is. But you could imagine, right, if you have more information, such as what the weather is, right? So if the road conditions are wet, right, would that have a factor into whether it takes longer to get to a destination? You mentioned GPS coordinates, right? In this case, it's not taking that into account. But if you want to be absolutely precise, you could certainly use that as an input, right? So in this case, we've selected these here, these features here. But if you were doing it in the real world, use case, you certainly, the more information, the better, right?
Interesting. So does like the payment type in this scenario like actually determine whether or not something's, the rate is inflated or not?
Yeah, that's a really good question. I don't think in this case that plays a factor, and that's there's some techniques in machine learning that you can certainly use to tease out that information, right? So one of the things that that's a really good question, actually. It's like, okay, well, is payment type, whether I'm paying with a card, cash, or whatever, is that actually impacting how much my rate varies?
Right.
In this case, we don't go as deep into that, but there's certainly ways that you could tease out that information.
This is awesome. I think this is a great little tutorial to walk through and kind of get, acclimated with ML.NET. And I hope our viewers will agree and they'll take time to take a deeper dive into that. There's other tutorials under this I see as well. So by all means, explore away. And should we just jump right away into the hallway track, you think?
Let's do it.
I think
Let's do it. Myra, were you saying something before we cut over?
I said, no, let's do it.
Let's do it. Let's do it. Awesome. So I just want to learn more about ML.NET. So I'm curious, like you've prepared, you have like slides and stuff. So you guys are like
we
really official.
Yeah.
I know you said this is unscripted. So we're kind of breaking your rules here.
Okay. Here's a slide deck.
Right. But this is the unscripted part, right? You weren't expecting this. So
True.
That's awesome.
So we already did introductions, so we can skip here. And Louise, do you want to talk about, first, what is machine learning?
Yeah, absolutely. So we'll start off with the slides, and mainly that's just for context setting. We know traditionally, we know that folks are doing machine learning, so that's part of the reason why ML.NET exists, right? And other tooling that does machine learning in the .NET ecosystem exists, right? But in terms of traditional .NET applications, right, the programming paradigm, it's just slightly different, right? So just this is more to set the context.
I got a question real quick, actually.
Yeah, go for it.
So you talked about like the .NET ecosystem, and we have one of our viewers, Lesker606, is asking whether or not ML is applicable with F#. Is that something, .NET ecosystem? I mean, there's multiple languages in the .NET ecosystem, F# being one of them. Is there SDKs for that? How does that work? Is that possible?
Yeah. Bri, do you want to talk? I mean, I have my opinions, but Bri,
Louise is a lot more opinionated, I think I should say he's a lot more passionate. ML.NET does support F#. We have several samples in our GitHub repo that, you have the C# version and the F# version. We could definitely give a little bit more love to the F# community, which I think Louise will talk about, and that is in our roadmap. But Louise, you want to say anything else?
Yeah, I think F# is the language to do this type of work in, right? Because you have, without getting too deep into it, right? F#, one of the things that it gives you is it's like really succinct, like Python. So Python developers can appreciate that. But then you got the compiler backing you the whole way, right? And you have all the .NET libraries that you use and love every day, right? So, and then the tooling, right? Like there's just so much there that awesome. I truly believe F# is one of the better languages to do this type of work in.
Interesting. So if someone wanted to learn more about F# specifically, should they check out any of your repositories, Bri or Louise?
Yeah, I would say so. Let's see, Louise probably put it here. Yeah, so our machine learning samples GitHub repo. So it's .NET/machine learning-samples. So this has, a ton of ML.NET samples here, and you can see like there's a C# and an F# version for quite a few of them. So definitely I would check this one out. Another really cool thing down here, maybe I need to zoom in a little bit, is we have some community samples. So these are so the samples up above are mostly, the team created those. This one as samples submitted from the community. So you can see here, and I think there's a few F# ones here as well, if I remember correctly. I don't remember where exactly it is, but yeah, I would say check out the samples repo for some F# examples.
Awesome. Thank you so much. Sorry to divert away from your beautiful slides. They are really well done, by the way.
No, it's part of it.
I'm saving my questions because I do have some, but I'm saving to like let them present, and then I'll ask.
Yeah, and if any questions come up, please feel free to ask. Like, it's scripted / unscripted, or at least this part. Yeah. All right. Let's see. Yeah, let's get into it. So, just to really briefly talk about what machine learning is. You're going to hear a lot of different sort of definitions of this, right? And some of the words can be interchangeable, and in a sense, they can be, right? And the reason is that you have this sort of like overall AI umbrella, right? And the AI umbrella can be thought of just very broadly as the tasks that typically humans would do that are automated, right? Or some agent performs them on the behalf. So you can think of, the spam filter on Outlook, right? That technically is AI because you're not the one that's, basically filtering those things out. Sometimes you may be setting rules to basically direct certain messages a certain way, and it's not you doing it. It's some sort of agent that performing it on your behalf. So you could argue that's artificial intelligence. The problem with that, though, is that it goes back to that idea that I was mentioning earlier that I alluded to, which is you're kind of coding this and you're telling the computer, hey, these are the rules and this is how I want you to do these things on my behalf, right? It's fine for small problems, but as you scale, right, you might imagine that the problem becomes much harder to code and to provide and set rules around, right? And it's a lot of maintenance to sort of upkeep, right? So that's where machine learning comes in. And machine learning essentially is a subset of artificial intelligence, and in this case, basically computers or these computer systems use examples to learn these patterns. So instead of you sitting there coding it, now it's using live data, historical data from previous examples to basically determine what the rules are instead of you having to manually code it. And then within machine learning, there's this sort of subset called deep learning, and basically deep learning provides a set of algorithms, right, typically neural networks that are better used in certain scenarios, and essentially they're just stacked basically learners or algorithms that basically help you predict and work really well, especially in image classification scenarios or image computer vision problems, speech detection and things like that. So that's kind of how they all relate. And just to kind of put it into perspective, artificial intelligence, if you were to go ahead and do this with artificial intelligence, right, is this a loaf or not, right? To the untrained eye, this might be difficult to discern, right? So how would you go about coding this, right? And I'm sure you might find things to code around it, right? But at some point, it's going to be like very hard to track down and very hard to sort of confine these rules in code. So in artificial intelligence, machine learning, instead of you providing it those rules and coding that up, you just give it examples. Here's examples of bread, here's example of loaves, and here's examples of pugs. And they still look pretty much the same, but after a while,
they do.
Yeah,
they do. It's like lobes with legs.
Yes.
I can't tell which is the bread and which is the pug.
They're both very lumpy.
God.
Oh my God.
But I'm sure that if you give it enough images, the computer will be smart enough to eventually be able to tell the difference, right? And that's different. So in one, you're kind of coding it, provided the rules, and the other one, you just give it examples, and eventually it learns the rules on its own. So what sort of problems can you solve other than determining, is this a loaf or not, loaf of bread or not? You can do essentially finding outliers, right? So in historical data, is there a trend that looks, different than what traditionally is the norm? You can predict numbers, so kind of like that taxi fare example, right? Trying to predict the fare. You can find relationships, like are certain customers, what makes certain basically clusters or certain groups of customers within a customer database, and how are they related? You can categorize items, right? So in image classification, in this case, loaf, bread or not bread. And the other thing that you could do is you could basically make recommendations, right? So think Amazon, here's your suggested items and what we recommend that you buy.
Awesome.
There's a question
Yeah.
from the audience from Obina. What are the .NET equivalent of scikit-learn, TensorFlow, and Keras?
Yeah, that's a really good question, and we can certainly we'll get into that later on in the presentation. So definitely, stay tuned for
Save
that.
it for later.
Yeah, we'll say that for later. But we'll answer that. Thanks for that question, Obina. Let's see. So there's a workflow typically associated with how you go about solving those types of problems. So first you figure out what exactly is that I'm trying to solve, and then you actually get to solving your problem, which is, you gather the data, right? That's front and center. You prepare the data, so if there's missing values, if maybe you need to basically combine different columns of data to help to basically create new columns that provide more information about the problem you're trying to solve. You then go ahead and choose an algorithm to train a model. You evaluate it to make sure that it performs well, right? You don't want to basically have a model that predicts, disease or tries to diagnose disease, and it's like, coin toss, right? It's if you have a model that's no better than a coin toss, and at that point, that's not a model you're willing to, risk somebody's diagnosis on. And then finally comes the deployment piece, and that's a really exciting part especially when it comes to .NET, is because now you've done all these things, but then you can also deploy to the applications that you know and love, and you essentially that you're familiar with. And on the consumption side, right, there's inferencing, which is just making predictions. It's another word for that. Yeah.
So that I just wanted to touch on something real quick there. So for me, like I've been somewhat familiar with ML.NET. I've consumed, sentiment analysis. I've done some of the demo stuff. I've looked at it, but when I try to approach it from like, net new, like here's a new thing, how do I determine like what's actually applicable to machine learning, right? So I've got data, but how do I know what data is relevant? How do I, like, step one there is almost like you say, instead of get data, it's like decide whether or not machine learning can solve this problem. Like, how do I do that?
Yeah, I think, so I'll give you the answer that everybody loves. It depends.
Use F#, right?
Use F#, yeah, exactly. It certainly depends, but I think a really good heuristic for this is if this is a problem that you can't necessarily come up with a really good sort of heuristic for how to solve it, or how to, if you're 3, 4, 5 if statements deep, right? Maybe machine learning might be a pretty good candidate for that, right? Especially if there's a lot of variability in terms of what those input parameters are that determine what the outcome or what the answer that you're looking for is within your application. There are certainly, of course, scenarios that you see where people, especially when it comes to marketing, it'll be like, oh, our platform is AI and machine learning and stuff like that. Sometimes you also have those marketing things, right, where it's like it's the hot word, and people will introduce machine learning where, as you kind of alluded to, right, sometimes it may not be the best answer, right? So it really does depend. But I would say a way to think about that is, if I'm spending a lot of time sort of tweaking these parameters and all these if statements to basically fit around this one thing that I'm trying to solve, maybe you might want to give machine learning a look.
Awesome, thanks.
Yep. So going back to Obina's question in terms of the ML landscape, so you have, as Obina mentioned, you have scikit-learn, which is for classical machine learning problems. You have TensorFlow that you could solve classical machine learning problems like regression, but you can also use it for deep learning, right? And you have PyTorch, which deep learning, Keras, which is kind of like a higher level API on top of TensorFlow. And then you have Onyx at the base, which is this format that allows you to basically take a scikit-learn model, convert it to Onyx, and then you can use it inside of TensorFlow, or you can use it inside of PyTorch, right? So it provides that interoperability piece for all of these frameworks that are out there, right? Now at Microsoft, there's various sort of things that you might want to look at. There's Azure Cognitive Services, which basically you can consume via just REST APIs. You have Azure Machine Learning, which allows you to train custom models. WinML, which allows you to inference or make predictions with inside of Windows PCs, right? And it provides hardware acceleration. And then you have ML.NET, which really is this framework that, in addition to allowing you to train and consume models, right? It also, in terms of your level of requiring sort of machine learning knowledge, it can be minimal. And going back to Obina's question of what is the equivalent of these external, typically Python, that's one thing to be aware of. Typically, these are Python libraries. What's the equivalent in .NET? You could say that ML.NET is kind of that, right? And the reason for it is you can train classical machine learning algorithms, and models, very similar to scikit-learn. The API provides that. You can train, at least for image classification, TensorFlow models. And the way that it does that is it uses TensorFlow.net, which is a library, a community library that's out there. You can consume TensorFlow models inside of ML.NET, and you can consume ONNX models inside of ML.NET as well, right? So it's not only can you do everything within .NET and sort of in a scikit-learn for classical machine learning problems, with ML.NET, you can also take models that were trained in other frameworks like TensorFlow, like ONNX, or not ONNX, but that have been converted to ONNX, and you can go ahead and consume them within your .NET applications, right?
So is ONNX like the glue between all those things then?
Yeah, in a lot of cases it is. Yeah. Yeah, sorry, go ahead.
I was gonna say there's another question related to this, which is maybe you already answered, but what are we missing when compared to TensorFlow? So you said that you can use TensorFlow libraries with .NET. So are we missing anything?
Yeah, it's something we've heard time and time again, which is kind of like, can you provide a KRS-like API to build custom neural networks? So you can't, at the moment, build custom neural networks using ML.NET. You can take TensorFlow models and consume them. You can train, in some scenarios, TensorFlow models with ML.NET, but you can't define the neural network structure inside of ML.NET. But you can, however, take TensorFlow.NET and define it that way, train your model there, and then use ML.NET to consume it within your .NET applications. So ML.NET sort of provides a platform for consuming those models, right? And again, in some cases, you can also train them. But if you want a little bit more control of that, you might be better served by using TensorFlow.NET.
All right. So you all must be really experts at machine learning after this presentation.
Pretty much, yeah.
So are there any other questions that we should answer before we have a few, just like 3 slides on what is ML.NET, and then we'll get into some demos?
I don't think so. I think the chat's quiet. They're in awe right now. They're like, oh my God.
They must be, and they're all experts. They know everything now. So what is ML.NET? Louise already kind of covered that, but essentially it's an open source and cross-platform machine learning framework for .NET. So a little bit of the history. Microsoft Research began this text mining search and navigation project to let internal devs easily add custom machine learning to internal products and technologies. That was in 2002. In 2011, they actually renamed that library to TLC, or the Learning Code, which has been widely used within Microsoft since then. In really common products such as Bing Ads. It's been used in Outlook, Microsoft Defender. So a ton of internal products. This library TLC has been used for machine learning. In 2018, TLC was actually made open source and cross-platform and rebranded as ML.NET. So the first public preview was released at Build of 2018, and it was made a little bit more, friendlier for .NET developers. Then 2019 at Build was the GA release of ML.NET. And then this year we actually had our first all ML.NET conference, which was the virtual ML.NET. So that's a little bit of the history. Oh, forgot to do the slide, but ML.NET runs essentially anywhere that .NET runs. So you can train and deploy on-prem or in the cloud, and then it's cross-platform, so Windows, Linux, and Mac, of course. And we really emphasize that ML.NET is built for .NET developers. We're not trying to pull, data scientists away from Python and their favorite, libraries and frameworks for machine learning. We just want to democratize machine learning for .NET developers. So, .NET developers can use their existing C# and F# skills to add machine learning to their .NET apps, and they don't really need that data science and machine learning experience in order to do that, in order to add custom machine learning.
So does it help though if you have like a data science background, or?
I mean, it can help, but the tools that we offer, and actually the next slide is about it, will allow you to not have to do that, because one of the biggest questions besides the data portion of, how do I get my data in the right format? How do I collect data? How do I label data? Beyond that, what algorithms do I choose, and what data transformations do I need? Like that's, one of the big questions that developers have. I literally have this quote from so many .NET developers saying, I'm not a data scientist, I'm a developer. Like, how do I choose these algorithms? So we actually provide, and I'll say that here, something called automated machine learning, or AutoML, that iterates through different models and algorithms and data transformations in order to get the best performing model based on the scenario and the data that you have, so that you don't have to choose the algorithm. You don't have to tune the algorithm hyperparameters. You can just get the model that works best for your data. So what that looks like is, so we've got the ML.NET API, which is, like I said, is cross-platform. And that's the NuGet package. There's Microsoft.ml. On top of that, you've got the AutoML.NET API, which is what I mentioned before, where you can have an experiment and just give it your data, choose your scenario, and it'll give you the best model based on the time that you give it to train. Also cross-platform. And then on top of that, you have our tooling. So you've got Model Builder and the ML.NET CLI. Model Builder is currently only in Visual Studio, but the CLI is cross-platform, and they have basically the same functionality. And we'll have some demos of that later.
We've got another question here real quick. So Paul Smalls is asking, can this work with the Microsoft Cognitive Toolkit?
Louise, you want to take this one?
Yeah, that's a really good question. So as far as I know, the Microsoft Cognitive Toolkit, or most commonly known as CNTK, it's been discontinued, right? So it's been discontinued and it's no longer. So we wouldn't advise, especially doing new workflows on CNTK. But if you already have existing CNTK models, I believe that you might be able to get this model into Onyx format. Don't hold me to that, but I believe that if you're able to get that into Onyx format, you should be able to then use it inside of ML.NET. So that might be a way that you could go about it. But like I said, it's been discontinued, and I don't think it's recommended that you do new workflows with CNTK.
Is there like a replacement for that then, if it's being discontinued, or?
Not that I know of. No. Yeah, not that I know of. I think folks either use PyTorch or TensorFlow or something else. CNTK was kind of that, right? Or Microsoft's version of TensorFlow and PyTorch. Yeah.
Cool.
And you mentioned Model Builder is Visual Studio only, so and we are currently in preview, right?
Technically, Model Builder is still in preview. That's only because we're making sure that it's as local, we're localizing it and making sure it's as accessible as possible. So once we get those checked off, then we will be GA, which should hopefully be pretty soon. But yeah, great question. And there's actually a community member, Franz Silva. They actually created a VS Code version of Model Builder. It's actually out there on the VS Marketplace, or I guess VS Code Marketplace, that you can download it, and it runs on top of the CLI. So that's pretty interesting. It's really cool. We're gonna start working with him on that. So, yeah.
Awesome. And we've got another question here, and blazerwasm WebAssembly is the new hotness that everyone loves. Being that this is .NET, does this work with Blazor WebAssembly?
Yeah, actually, Louise has written quite a few samples about it. So, Louise, if you want to talk about blazerwasm.
Yeah, this is the thing that I wanted for the longest time to happen. And as of .NET 5, right? .NET 5 was sort of that one thing that made everything happen, right? And I suspect .NET 6 will get even better. But as of .NET 5, yes, the answer is yes to that. You can have your models. And in fact, I don't think I included it in the links, the URL list links. But we do have somebody who came on, Bart. He works at Microsoft, and he created this sample where his application, it actually runs many different models that are supported by ML.NET, and he hosts it on GitHub pages, right? So there's a blazerwasm, application hosted on GitHub pages. So he's paying pretty much nothing for the hosting of that. He's got the models hosted on there. And you get all of the interactivity and the same experience that you would expect out of these applications. And then you take that a step further, right? Because you're able to turn these applications into progressive web applications, or PWAs. Now you have it also running offline in your platform of choice, right? Linux, Mac, whatever it is, right? That supports PWA. So that's the long answer. Short answer is yes, it does work as of .NET 5.
Yeah, and so I think that was 2 community stand-ups ago that we had. Was that? Yeah, 2 ago. And then last time, which was a week and a half ago or something like that, we had Franz on talking about the VS Code extension that he built. So go check those out if you want to learn more.
That's awesome.
And we'll try and find that link too. Louise, maybe we can find Bart's link so we can show that off.
Yep.
All right. So here's some of the things you can do with ML.NET. I think Louise kind of covered these earlier. For examples, classification can be things like, I want to know if these, comments coming in for the .NET Doc Show are positive or negative, or if they're spam. Regression can be, price prediction. I want to know how much this house is going to be worth based on the number of rooms, the location, and such. Forecasting can be, predicting future sales based on past sales, or, predictive maintenance. Anomaly detection, you can, identify transactions that might be fraudulent. And recommended cluster, or where are we? Ranking could be like search results ranking, clustering, customer segmentation, recommendation, frequently recommended products, or, movies to watch on Netflix. This is recommended for you. So those are what we would call the classical machine learning task, and these you can train custom models. And then we've got image classification, object detection. The difference here is with image classification, you have an image and there's only one label. So you're saying this image is a dog, this image is a cat, versus object detection. You can actually detect and locate objects within an image, and you can have multiple objects within an image. So you can say, in this one image, here is the dog, here's the cat. And so for this, you can train custom models through our tooling. Also, we have an image classification API that you can use a method called transfer learning to get custom image classification models. And then you can also consume Onyx and TensorFlow models, as Louise mentioned earlier.
Well, there's a lot there. I'd almost put this slide earlier in the deck, because this answers the question about like what data do I have to bring? Like what that answers my question I had before.
Yeah, and that was one of my questions, because I work on that taxi fare tutorial for the first preview, for the first for build 2018. And I remember the image classification wasn't there, right? So it's like we supported only a few tasks at the time, and that set of tasks started growing. So do you plan to expand these tasks beyond this? I don't know what else you can. I'm not an ML expert, so
yeah.
What else is missing here?
Yeah, so we have a roadmap for later on that we'll talk about, but I can definitely answer that now. So we've been looking into NLP, or natural language processing. That's one. Well, we have like classification, which you can kind of use for sentiment analysis. NLP is a bit better for those sort of scenarios, so we're looking into that. What else is there, Louise? What other scenarios might we be coming up in the pipeline?
Yeah, I think that's the big one, right? That's definitely of interest to people, especially now, right? You're hearing of new architectures coming out, like transformers, which are state of the art, right? And GPT-3 and all those things, right? And that's sort of the cutting edge stuff, right? But even if you take it back, right, and use more proven technologies that are in the and just take it back, NLP stands for natural language processing. Yeah, so that's definitely one of great interest that is certainly not there at the moment.
Yeah, the other thing here is all of these tasks are right now in like part of the ML.NET API, but not all of them are part of AutoML.NET yet. And so we're working to add all of the ML.NET scenarios to AutoML.NET. So again, we can remove that complexity of having to decide the algorithms and the hyperparameters and the data transforms. So currently we have classification, regression, and recommendation for AutoML, and we're looking to add all the rest as well. And once we get into tooling, I can kind of show you what's supported and what's coming up.
That's awesome.
Yeah, great question. This is the last slide for this. So just like, when would you use ML.NET? And, if you want to stay in the .NET ecosystem for custom machine learning, that would be the biggest one. If you don't want to worry about low-level complexities of machine learning, using AutoML is a great resource, or a great way to get started. And then if you want to train a custom model, I can already said that, or if you want to consume a pre-trained model in your .NET applications. So let's get into a demo, unless there's any questions.
There is one question, and I will pronounce it like, it sounds like a Brazilian name, so I'll pronounce it in Portuguese. So Momedes asks, do you plan launch in the future another algorithms like MLP, for example?
I'm not sure if MLP is NLP, or unless Louise, you know something that MLP stands for.
There's only one other thing, which is like multi-layer perceptron, but I think it might be NLP in this case. So if you can clarify that in the chat, that would be great. And the NLP piece, right, I think we just answered. MLP, meaning can you build your own neural networks, you might be better served at the moment to use something like TensorFlow.net.
And another question is, what about Louise models? Is there a scenario where we can run them locally?
No. The short answer to that is no. Part of that is because that is as far as I understand it, you can, it depends. So you can run it in containers.
Yes,
right?
yes, I was just going to say.
Yeah, so you can run it in containers locally, but you can't run them inside of sort of like ML.NET won't run the model for, like you can't say, hey, I want this Lewis model to run in ML.NET, right? So that you can't do, but you can run Lewis locally in containers. Again, the other thing to keep in mind there though is that you're still getting built for it, right? Even though it's running locally, that still doesn't mean that you're not getting built for it. So that's a slight distinction. But can you do that with ML.NET? The short answer to that is no.
And last question from the thread, Cam is asking, how good is AutoML? As a novice, am I better off using AutoML or taking a few days to figure out what I'm doing without it?
Yeah, that's a great question. So AutoML is not like a replacement to data scientists. It's more of a supplement. It's, you know, when you're doing machine learning, it's very experimental. And if you think back to the workflow slide that we had where, you know, you prepare your data, you train and you evaluate, that's very cyclical where you have to keep going until you have a model that fits well for you. And then even then your data can change and you might have to retrain. So I think, honestly, my opinion is starting with AutoML is great. And then that actually, with our tooling, it actually gives you the training pipeline. So it's a great way to even learn. So you can use AutoML to train, get the training pipeline, and then see what algorithms and hyperparameters it chose. And then you can even tweak the pipeline from there. So you have a great starting point from ML.NET, and you can continue to iterate if you wanted to. Louise, anything to add there?
Oh, I think you hit it right on the head there.
Yeah. So since there's no more questions, I'd love to get into a tooling demo.
Whose screen do we need to share?
Oh,
Is that...
I will. Yeah, it's my screen.
Okay.
All right. So here we've got VS 2019. This is just a .NET Core console application. Hello World prints Hello World to the console. So my business problem here is I want to use object detection to find stop signs and images. You can see where this might be really useful in self-driving cars. So I'm going to show you how you can do that with Model Builder. Here's my project. I'm going to right-click on my project and hit Add Machine Learning and wait for it to load. All right, so this is Model Builder. This is what it looks like. You can see these are the scenarios that are supported by AutoML, like I mentioned earlier. These are limited scenarios where they're not yet supported by AutoML, but we won't, leave you on your own. We'll link you to some tutorials and samples. In this case, I want to train with train an object detection model. Another thing to note here is you can see these little tags here will indicate if you can train locally and or in Azure. So these are our local scenarios. And then image classification is the only one that has Azure and local, but we're working to add both local and Azure to all of our scenarios. So let's go ahead and go into object detection. So right now, object detection, you can only train in Azure. So what you'll do is set up a workspace. And this is actually connected to Azure Machine Learning. So you can create an Azure ML workspace right through from the UI. So I'm going to select my subscription here, ML.NET Model Builder Demo. If I wanted to, I could create a new workspace right in the UI here, but I already have one set up, which is this demo workspace. Then a compute, again, I could set up the compute here in the dialog, but I have one set up already. So from here, when I hit create, this actually creates a new workspace with all the settings that I gave it and gives me a summary here. And the next thing I can do is actually choose my data. So for object detection, it's in a very specific format right now, and you can see how do I format my JSON. It has kind of this example of what it should look like. We recommend using VOT, which actually will spit out this format here for your data. So I'm going to show you what that looks like. VOT is just an open source image labeling tool, and this is it here. So what I've done is I have, I think, 57 images of stop signs that I got from, what was it?
Unsplash?
Yes, Unsplash, which are, a bunch of images that they let you use for that. There's, one of the licenses, you can use it for whatever you want. So what you do here is you draw these bounding boxes around, you know, the stop sign in every image, and then you would tag it. So I added a tag stop signs. I would draw a bounding box, add stop sign, and do that for the 57 images. Then what I would do is export it, and it exports in that JSON file that I need. So going back to Visual Studio, I will find my data in that JSON format. And once I do that, it will actually show me a preview of what my data looks like. So you can see it shows me the first, I think it's the top 4, and it shows where the bounding boxes are and what that label is.
Oh,
Yeah,
fancy.
And so
I love this.
yeah, and so the next step, once you take a look at your data, you say, okay, there's 57, that matches up. You can then start training. When you start training, it will send your data set up to Azure ML. It will train in Azure ML, and once it's done training, it will send the model back so you can start using it locally. I'm going to not do that right now because it took, I think, 14 minutes. I have another instance of VS open where training was done. We got a model back that had an accuracy of 91%, which is pretty good. I think it took like 13 or 14 minutes. Math is hard, so I had 843 seconds, whatever that is. And so you can also actually, it'll link you to the Azure ML portal where you can actually look at the run as well. So then in the evaluate screen, I can actually choose images and evaluate my model to make sure that it's, you know, working up to standard before I actually start adding it into my app and getting the code. So you can see I had input this image already, and it said with 99% certainty, this is a stop sign.
So out of curiosity, is that where you would typically take an image that you didn't train against?
Exactly. So these are images, these are test images that were not part of the training data. Yep.
Okay.
That's a great
Got
point. So let me try one, you know, a bit more complex that has 2 stop signs in it and see what happens.
Ooh.
Yeah. See if we can game the system, game the model.
They really need to stop there, like people.
Yeah, I don't know what this came up when I looked up stops, like 2 stop signs. It came up with this double stop sign. I think it was from like a Wikipedia article, and I did not actually read why you would need a double stop sign.
If it's a 4-way stop, does that mean that you stop 8 times or 16 times or?
I'm really not sure. And let's see, I'm sharing my screen and this is taking up all my resources. So we'll see how long it takes to actually detect the objects in the image. Maybe it's longer, twice the time because there's 2.
We can just keep doing jokes. No.
Yeah, exactly. So there we go. It actually detected both of them. It said the top one, we're 99% certain that it's a stop sign. This bottom one, we're about 87% certain.
Oh, wow.
So that's where the score threshold comes in. As you start to change the threshold, you can see if my threshold's at 90% or 0.9, it's not going to show the one that was 87%. So anything under 90% of confidence, it's not going to show up. But you can see when I get to 72%, it actually thinks that this is a stop sign here. So, you know, I would want my threshold then to be above that so that it would only, you know, show those stop signs. And obviously, I only trained with 57 models and actually did a pretty good job, or sorry, 57 images, and it did a pretty good job. But when you are using this for self-driving cars, you will want to train on a lot more images of different angles, different colors, you know, different lighting. You want it to be as accurate as possible, so it will detect those stop signs and stop. So yeah, the next step here would be code. So I've already added, so it actually generates this code and I've already added it to my solution. It's this console app and class library here. The class library has an Onyx model. So when it actually trains up in the cloud with Azure ML, it actually produces an Onyx model, and then we convert that to an ML.NET model. So you get both the Onyx model and your ML.NET model. That's a serialized zip file. You also get your model input generated, which is you know, the label, which is, you know, stop sign, and then the image source, so where that image is, and then the output, which in this case it's a little complicated here because it you know, with bounding boxes and labels and scores and such. But with classification, you know, you'll get back a prediction and a score. With regression, if you're trying to do price prediction, the output would be that score or that value. And then we actually provide this consume model class here with this predict method to make it really, really easy, where you can just call this predict method and create a model input, call this predict method on that input, and then get back the result. And so in this console app that's generated, we show an example of how to use it. So in this case, you can see you would have new model input and set the image source here, and then you would call that predict function to to get the result, and then you would print that out to the screen.
Can you zoom in? We have someone saying that
yes,
it's hard for them to see.
Definitely. I can definitely do that. I thought 175% would be good, but
yeah.
Hopefully this is a bit better. I have word wrap on so that you can see everything.
Awesome.
So this is the sample code. For local scenarios, you actually also get back, like I said, that training pipeline. You don't get that back yet for ones trained in Azure. But if I trained, let's say, an image classification model locally, then you would get back the pipeline of the algorithms and the data transformations that it chose. So in my original one, I would have copied the code and put it in here. I already did that. I got rid of the hello world and I declare my model input, in this case, that double stop sign here, and then call that predict function and printing everything to the console. It's not going to be super visual, but you can see, we'll see how long it takes here.
It's functional, and that's all that matters. We do have a couple other questions.
Yeah, I can answer those while this is going.
Let me pull those up. So, can someone suggest an idea to make ML model for an image regression example? I think you provided in your sample repository, you had some for that, right?
There's some image classification examples there, yeah.
Okay.
Louis,
and you can also check the docs.
Yeah, of course. We have a few. We have both how to, so we have a tutorial for how to consume a TensorFlow model for image classification. We have a doc on how to create a custom image classification model using our image classification API that runs on top of TensorFlow.net. And then we also have, do we have one for image classification and model builder yet?
There's no tutorial, but there is a sample for it.
Yes, there's a sample, but not a tutorial. That's something we're working on. But so this actually ran, and you can see I didn't set a threshold score here, so it actually detected those three that we saw when I showed it in the UI, and it gave the positions of the bounding boxes and the label and the score, so you could see how you might input this into a web app or something more visual, and it would actually draw the bounding boxes around it. And one of our samples in the GitHub repo actually has that example.
Awesome.
Yeah. So in 5 minutes, we created an object detection model.
Yeah, that's powerful. Cam asked the question real quick. He says, what does the contents of the zip file look like?
Nothing. It's not really human readable.
Okay.
It's but
like a binary or something.
Yeah. So the model, it just has the different data transformations, the inputs, the outputs, the algorithms that were chosen. That's kind of what's contained in there, so that when you feed it new data, it will give you the prediction based on all of that before.
Awesome.
Louise, anything to add there?
No, yeah, it's not something you would try to decipher. It's just something that's that's serialized and encompasses all the information that is captured from the training process.
So Cam is from the Matrix, and he reads the flowing binaries. That's what he's expecting.
That makes sense. In that case, yeah, it might make sense.
And Mohamed is also and sorry if I'm pronouncing it incorrectly, also said the MLP that he was referring earlier is multi-layer perceptron. So he confirmed that.
Yeah. And then, so going back to that, right, you will want to use TensorFlow.net to train custom or build custom neural net models.
I feel like I'm in like Avengers Infinity War, like with Iron Man, multi-layer perceptron. It just sounds really...
It really does sound like that.
Put a Tron into after the word.
Oh, God. Awesome.
Any other questions before I move on to our next demo?
No, I don't think so. Not right now.
Okay. So let me try and zoom in here because I see some people can't see. So now I'm going to show the CLI tool. For those of you who might not use Visual Studio or are not on Windows, we have what's called the ML.NET CLI. And I'm going to show a sentiment analysis example. Sentiment analysis is when you have text and you want to predict if it's positive or negative. It's used a lot for basic examples or intro examples, kind of the hello world of machine learning. So I'm going to show you what this data set looks like. It's just a text file separated by tabs, and you can see the first column are comments left as Yelp reviews. Looks like restaurants, talking about waitresses and food. And then the second column is the sentiment. So it's going to be, this is positive. So wow, love this place is positive. Crust is not good. Well, that's pretty negative. So I'm going to show you how to train a model with the CLI. And I think, let's see if I have it still. Oh, so the command here is going to be MLNet. This is just a .NET global tool. You can do, .NET install, tool install MLNet. And this is what it'll look like. You can see right now we support classification, regression, recommendation, and image classification scenarios. In this case, it's going to be classification with tabular data. So I will show you what that looks like with all the different options. Hopefully this text is big enough. You can see here, these are all the options that you can have. There's really only 2 required options here, which are choosing your data set and then choosing the column that you want to predict. And then, you can choose to ignore some columns as features. You can, say if it has a header or not, although we try to determine that automatically. And then you can also set the train time and such. So I want to make sure I spell it right. Train an image classification model with the data set that's Yelp comments.txt, and the label column is going to be sentiment. As we saw before, we want to predict the sentiment, and then the train time, I'll say just 20 seconds. Hopefully I typed all that correctly.
So while that's going, out of curiosity, I'm kind of confused by like the train time. So is there like a trade-off? Like if we just let it go forever, does it just get infinitely better? Or like, how do you know how long to do something?
Yeah, that's a great question. So in this case, both Model Builder and the CLI are running on that AutoML that we talked about. And this, if it's local, it's automl.net. So the time you give it is determining how many iterations it goes through. Oh no. So in this case, actually, this is a great example. So it says training time finished without any models trained. So this means I didn't give it enough time to iterate through enough models, and it actually didn't find one complete model here. So in this case, I would want to increase the time.
I was going to say that'd be really cool if there's a way to like specify like a minimal of 1. So you say min 1, and it does it long enough to at least get 1 model.
Right. Yeah, that's a great point. That's not something that we currently have, but I think it's something we've talked about in the past.
Feature idea.
Yeah, you file a bug in our GitHub repo. Let's see, and because like I said, my video's on and I'm sharing my screen. My CPU is kind of not happy, so we'll see if it actually finishes. Louise and I have this running joke that I've never had a demo fail on me. And every time I say it, I know every time I say it I jinx myself, but as you can see it worked because it found an algorithm here. So you can see it actually did find, when I gave it more time, it was able to run through that first iteration, and it found this trainer. It was about 80% with accuracy here, and what it actually does is it will what it's supposed to do. We'll see if the whole thing finishes. It actually generates the code for you, the same code that you saw in Model Builder. It'll actually generate that code as well. So it'll have the train. Let me see if it actually generated the code. There we go. Okay. So there it indicated, hey, the code was generated. Check out this. Check out where it is. So I'll show you what that looks like. It should be on my desktop.
Awesome. It took 20.9 seconds, by the way. So 21 seconds. So
yeah.
Very, very close.
And I don't think I said this before, but the larger your data set, the more time you want to give it to train. We have in our docs, we actually have a section where it kind of breaks it down by data, the size of the data set, and how long you should train for. But there are more factors. Like that's a very simplified way of looking at it. There's more factors to look at. Their size could be actual size, or like file size, or it could be number of rows, number of columns, number of features that you choose. So
interesting.
It can be dependent on a few different features. Yep.
We did have a question here too. So what's like the level of proportion for council applications being used today? And I'm assuming they mean because you can do this from a GUI or you can use this, the CLI. And when is this helpful versus one? I mean, I'd imagine with continuous integration or something like that.
Yeah, exactly. So the first one would be if you don't use Windows or don't use Visual Studio. Right now, our version of Model Builder is only in Visual Studio, but now Friends does have Model Builder in VS Code, which you can use, but it doesn't have all of the scenarios just yet. Once it catches up, then that will be totally great for VS Code. But the other option is the CLI. But then, yeah, for CI/CD purposes, this is where the CLI would definitely come in handy.
And we have another question here. They didn't see how you specified the file path for the training in the CLI.
Yes. So I was just on my desktop, and it was on my desktop. So I just did
So
the
it's
name of it because it was already on my desktop.
relative to your
It's
root.
one of the parameters, right?
It is
that
one
you
of the
pass.
parameters. Yep. So I'll show that again here. So what I did is ML.NET is the tool.
Mhm.
I chose classification as my scenario. That's the model that I want to train. My data set is one of the parameters here. So it's Yelp comments.txt, which was already in the desktop.
Got it.
And then the other required one is choosing the label column. You don't have to specify train time. I forget what the default time is. I think it might be 60 seconds, and I didn't want to train for that long. So I specified train time as well.
Awesome. Cool. Well, we've got about 5 minutes left, and I don't think we
Wow.
even saw.
It's flying by.
Yeah, there's been a very engaging audience. They've been asking lots of really good questions.
I didn't even get to Louise's. I'm so sorry.
know.
No
We're gonna have
worries,
to
no
come
worries.
back on again.
Do you want to show something real quick? Maybe like 3 minutes with zip through something?
Probably less than that. Yeah.
Yeah.
We could switch over. It's really just, so in this case, you've been seeing console applications, and what I have here is a WPF app, right? So pretty much the same concept. Going to the taxi fare. Let me see if it zooms in at some point. Yeah, there you go. Right. So you have all those inputs: the vendor ID, the rate code. So if I were to go here, CMT, rate code 1 or whatever 1. So and then 3 here, hash. When we hit predict fare, right, it predicts a fare that is going to be $42 for this particular trip, right? Behind the scenes, there's nothing special going on, right? As you can see here, we are using the prediction engine, which is the convenience API that allows you to make predictions on a single instance of data. So in this case, our data is these inputs, right, which are being captured from the WPF application, and then we decide the prediction engine predict, right? And that's what gets displayed eventually out there. So as you can see, right, as long as you understand the concepts, you can then just take that and embed that inside of your existing applications. In this case, it's a WPF application, but again, WASM, blazerwasm, ASP.NET, web APIs, Azure Functions, whatever it is, wherever .NET runs, you can essentially run this code.
So really the work with ML.NET is kind of figuring out your data, training your model, and then plugging it in, right?
Yep.
So it seems like it goes anywhere .NET goes. You just kind of plug it in once it's been trained. Again, all the hard work's, kind of preemptive efforts. And then you have it and you're good to go. That's awesome.
And the thing that I missed here, actually, which is actually the real key, is this model was not an ML.NET model. This actually was trained in Azure Machine Learning with Python. And I just converted to Onyx, and then I just consumed it in here, just like I would consume a traditional ML.NET model.
Oh, wow. That's so cool. I feel like such a nerd. I'm just like, so exciting. Go ahead. Sorry.
No, you mentioned Visual Studio and CLI. So for Visual Studio, is it Windows only, or is it a Visual Studio for Mac as well?
Windows only, I think.
Yeah, Windows only. Sorry.
Okay. That was my okay.
So I do see that we're running low on time.
We are.
There's a few things that we kind of wanted to bring to your folks' attention, upcoming events. We have the machine learning stand-up, community stand-up, which happens every other Wednesday. There's one happening this Wednesday. And we're gonna have.
Actually, I have the visual there. There
awesome.
we go.
There we go.
So they can continue the conversation about ML.
Exactly,
Awesome.
exactly. And we're gonna have Don Syme this Wednesday. We're gonna be talking about PyTorch. Torch Sharp, which is the PyTorch .NET bindings for PyTorch, and tensor programming. So we're gonna have that. That's really exciting. On the 10th, it's gonna be .NET Conf, and Bri's gonna be showcasing some of the wonderful work that customers are doing with ML.NET in production. And last but not least, we have the ML.NET Hackathon, which will take place on November 13th, and it's a week-long event where you can come and build ML.NET applications and hopefully get T-shirts, get swag, and
We've got already 6 really cool submissions. I think one of them was detecting face masks, which is really relevant. So you can either submit a new project, join an existing project. We'd love to have you all as part of the hackathon. And you don't need ML.NET experience. We'll actually be running an intro workshop or an intro session right before it's the kickoff of the hackathon. So
Really
Awesome. This has been great. Thank you so much. That actually just reminded me, Luis and I, for the Microsoft hackathon, we spent a little bit of time kind of looking into stuff like that, like the face mask and whether or not it's being on properly and stuff like that. Oh, so cool. Is hackathon online event?
yes, all
Yes.
online.
Awesome. Great. Well, this has been amazing. Thank you so much, the both of you, for coming on. I learned a lot, as always. Amazing shows. Thank you.
Yeah, no,
Thanks
thank
for
you
having us
having
on.
us.
Yep. And I think that's it. Next week, we're going to have Bruno tune in. Looking forward to it. Thank you.
Awesome.
Thank you all.
Bye, friends.
Bye.
Bye.